Hello, and welcome to Microsoft Hates Greg. In this episode, we are going to be taking a look at what has become one of my favorite measures, and that is Cthulhu, as well as a related measure that was created years later, Bride of Cthulhu. Now, if you're wondering about my pronunciation of Cthulhu, or some people may say Cthulhu, there are actually not just one, but seems like dozens of YouTube videos on the correct pronunciation of Cthulhu. I'm not joking. This is why we invented the internet, is to get information like this out there to the masses. So anyway, continuing on, Cthulhu, the idea behind Cthulhu is a repeating counter that resets when a certain criteria changes. So I actually included a Cthulhu in my book, DAX cookbook, as repeating counter with criteria, which is a far less fanciful name. Now, as you can see here, Cthulhu, the measure or the column, but the measure that we're going to be focusing on, as you have this animal tiger, it counts up 1, 2, 3, 4, 5 because these are all in sequence. And then when it changes to lion, the Cthulhu resets and starts counting back from 1 again. 1, 2, changes 3, changes to tiger, 1, 2, elephant, 1, 2, 3, back to tiger, 1, 2, 3, and so on. Interesting tidbit about this actually is when this problem was presented to me, I thought that the individual that was posting the data had gotten tired of apple, pear, orange, right? Turns out the individual actually worked at a zoo, and so this was actually like real data to this person. They have to count tigers and lions and bears and such. So now, why is it Cthulhu? Where to get the name? Well, the joke was at the time was that the mental gymnastics in order to figure this measure out nearly drove me insane, right? So if you follow the Cthulhu books, anyone that sees Cthulhu goes insane. So anyway, let's dig into the measure, right? So the measure here, and I've cleaned up the formatting, as you can see here, for all of our sanity, so we can actually read this thing. I'm just grabbing where, my current index within this table visualization, what is my current group that I'm in. I'm creating a temp table with var where I'm filtering my table for all of the animals and any index that's less than the current index. It's actually kind of an important piece of this in terms of how this was constructed. We could have done it with a greater than or less than or equal sign, but anyway, this particular version when I created it used less than. We'll create another temp table here, and what you see here is I'm adding this column diff, which is calculating the difference between the index, my current index, and the previous instance of that animal in that index. So, and you can see I'm using earlier here, which of course there will be advocates that say you should use var and return, etc. I have a whole blog article on in defense of earlier, but essentially you can think of earlier, and it's kind of weird to see it in a measure, right? But we're an add column, so we have row context that we can use earlier. Earlier simply, current row, essentially. So the index is less than my current value of the index in my present row is the way to read that. I also have this odd animal equals earlier, which I don't really need because I've already filtered out the earlier, but animals, but whatever. Figure out the current max index in the current filtered table. So all I'm doing is grabbing the max value of index in table 2. And then I am doing the max start, which is essentially saying where's the last skip that occurred. So if you think of a skip between these, skip essentially occurs when this index and the previous instance of that category, and when it's a sequential 5 to 4, that there's going to be a difference of 1, but from 9 to 5, there's going to be a difference of 4. So that's what basically max start is doing, is grabbing. So then I can filter out anything in my table with a index and that is less than the max start, essentially, right? So I'm going to grab at a table 2, I'm going to grab the index that is greater than or equal to max start. because anything prior to that is basically garbage data that I don't need. And then essentially I have an if statement at the end. Now, this is all well and good to go through and explain this, blah, 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 but what I thought would be nice for the video would be to show you a peek inside of the measure. So what I've done here is I created a duplicate page, and I've created measures for each step along the way. So each var statement that appears in Cthulhu, I have a separate measure for it, and I can return the value so you can actually see what's going on inside. And I use this troubleshooting technique pretty regularly when I am dealing with really complicated measures that are twisting my brain into knots. But as you can see here, so each one, so let's see, temp table one. So temp table one, as you can see, it's the Cthulhu code, and then I'm using concatenate X to return the indexes that are in that table. So as you can see here, for the first row, there are no previous rows, so it comes back blank. For 2, it only has just 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Then there's a skip, or then there's a change, and lion has never appeared in the table, so again, goes back to blank. And then the next one for 7 has the row for 6, 6, 7, switches back to tiger. Now I have 1, 2, 3, 4, 5, which are the previous rows. And then here in 10, I have 1, 2, 3, 4, 5, 9. So you can see that there's obviously been a skip involved. And same thing for elephant, and then tiger, 1, 2, 3, 4, 5, 9, 10, 1, 2, 3, 4, 5, 9, 10, 14. Another skip has occurred that we're going to need to account for. So that's temp table 1. Temp table 2 then adds that difference column. And this is how we can identify those skips, right? So we have only a difference of 1, difference of 1, difference of 1, difference of 1. We get up here, difference of 1, difference of 4. So now we know that there's been a skip involved. And same thing when we get down to tiger, 1, 4, 1. The max value that I referred to before, so that's the max value in our current table. Table 2, which remember is all previous rows from that include the same animal, all previous rows that include the same animal, we're grabbing the max value of the index in that table. So you can see how that counts up 1, 2, 3, 4. We get 6, 7. We go back to 5, 9. We have down here the tiger, we have 10, 14, 15. Now the max start, that is the maximum of the index where it's greater, the difference is greater than 1. So you can see here, since we have 14, 4, that value becomes 14. Again, when we have 14, 4, 15, 1, that value is 14. We can then use this value in terms of the skip in order to filter the table again, which is table 3. Let's take a look real quick at table 3. So we're filtering temp table 2 where the index is greater than or equal to the max start. So now we have filtered this table, table 2, and we can filter it down to just the rows that we care about, which is things like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 9, 10, 9, 10, 14, 14, 15. Now the final step, again, is with the Cthulhu full measure where we're saying if is blank max. So any row that there have been no previous instances of that category, we just assign them a number of 1 because they've never appeared before in the table. So we know we're at the start of a sequence. The next piece of it, if the max equals the index minus 1, then we just count the rows in their table and add 1. So that accounts for, like down here, for example, 15 and 16, we have 1 row in our table, 1 plus 1 is 2, we have 2 rows, 2 plus 1 is 3, and then the last boundary case, which is accounting for places like 14 and like 9, for example, where if that max is not equal to the index minus 1, then we just return 1 because we know that we're in the first row after a skip. And so that is how we account for row 14, where we're on 14 as the index, the max is 10, the difference is not 1, and so we know we're at the start of a sequence and that we assign it the value of 1. So there you go. There's kind of an internal look at Cthulhu in terms of what is going on inside of the measure as it's going through its calculation. Now, let's kind of switch gears here to Bride of Cthulhu. So Bride of Cthulhu came about years later, I was working, Don Kernan, who works at a transplant company, brought this issue to the forums. And I believe, if I remember the history, it reached out to me, kind of back channeled in messaging, and said, "Hey, I found this Cthulhu measure. It looks kind of some similar to what I want. Can you help me out?" And we ended up actually emailing back and forth, um, and figuring this thing out. And the spin on Kulalu, on Bride of Kulalu, is that, as you mentioned, as you saw in Kulalu, it was all a single table was involved, right? Well, in Bride of Kulalu, we have these things where it's multiple different data models or tables in the data model. So we have different facilities, we have a date table. Here's our case table, which are our fact table, and we have then this other table here, which determines whether or not the patient recovered or didn't recover, apparently. So much more complicated, not overly complicated, but definitely more complicated than a single table. And we needed to be able to filter by date ranges and by different facility IDs. And the interesting thing about this one really is that this DIM table here, where we track whether or not the patient recovered or didn't recover, there's no index on it. So we don't know what the order of these are, which is kind of important for Kulalu. We need to know what the order is. So the order actually comes from our fact table, which has a date. So not an index, but we have a date. And so that's good enough, right, in terms of determining order, which came first, which came last. So we needed to obviously modify Kulalu in order to come up with a measure that worked within this data model. So if we take a look at Pride of Kulalu, what's going on here is, again, we're doing the same. We're grabbing our referral date time, current date time of the fact, right? So in this visualization, these things are coming from the ops table, the DIM table, if you will, and then we're grabbing. We have to grab this date time needs to come out of the fact table, the related. There we go. Referral ID, I believe is. Yep, referral ID is what relates the two tables. So back to Bride of Kulalu. I can actually navigate. So we're just grabbing the date time from the fact table. We're grabbing our group again, which is whether or not they recovered or didn't recover. That's our grouping. And then here's our temp table. And all this temp table was doing is just grabbing the DIM table that we need with our, again, we're grabbing any of the referral times that are less than our current referral time. So that's all that table 1 does. We're going to add in this case, we don't have an index column, so we're going to add an index that we can do based upon our date time field. So all temp table 1A is doing is adding that index column. So a dynamic index where we're just counting the rows where the date time is less than. Here's our old friend earlier again, our current date time. Temp table 1B, we're now filtering that. So this is actually has all of the ops, whether they're in our group or not in our group, and we've assigned an index to them. We then filter that by the current group that we're in, and now we're going to have skips involved, right? Just like Kulalu, the original. So once we have that, we can create temp table 2, where we add our difference column, just like Kulalu. We grab our max start, we filter based upon our skipping, the latest skip that was involved, which gives us temp table 3. And then down here, we have the equivalent of that if statement, a couple additional boundary cases, and the conditions are a little different because of just the construct of this versus the original. So if is blank max, we return 1. If the max equals the max start in this case, we return 1. And then otherwise we count the rows in our table. So a little bit of a variation on Kulalu, but the same basic concept, if you will. So there you go. There is Kulalu and Bride of Kulalu. Now, Bride of Kulalu is not in Mushkookum. It may appear in a subsequent release of supported measures.json, but I figured since I'm covering Cthulhu, I might as well cover the evolution of it. The other interesting thing to note is Don Kernan was actually working on a different, her own version of this measure, right? And we ended up calling that Bridesmaid of Cthulhu. And actually, if you want to see it in the actual Bride of Cthulhu, it's actually composed of multiple measures, which is these two right here: consec referral date time and then consec reset date time. So those are equivalent. Consecutive donors and consec reset date time. If I remember correctly, consec donors. Yep. So consec donors, if I'm not mistaken, that one uses consec reset date time. So this is grabbing her group, if I recall, and then anyway, I babble. So there you go. There's Cthulhu and Bride of Cthulhu and Bridesmaid of Cthulhu in terms of covering how those measures essentially work. Hope you enjoyed this episode. Like and subscribe and all that fun stuff, and I'll see you next time.